All right, let's talk about something we use every single day, but probably don't think about much: the invisible grid that wraps our entire planet. It's this amazing system of imaginary lines that doesn't just let us pinpoint any location on Earth, but, and this is the really cool part, it also helps us tell time. So, yeah, let's dive right in. But first, a question for you. How would you describe your exact location on Earth if you didn't have a street address? Seriously, think about it. You're in the middle of the ocean or maybe a huge desert. How do you tell someone exactly where you are? That's the big puzzle we're going to solve today. Okay, so here's how we're going to tackle this. First, we'll start with Earth's twin, the globe. Then, we'll add the horizontal belts we call latitudes. After that, we'll slice it up vertically with longitudes. Then, we put it all together to create the grid that pinpoints location. And you'll definitely want to stick around for the last part, where we see how all of this connects to time itself. It's going to be great. All right, first things first. Our journey has to start with the most accurate model of our planet we have, and that's the globe. Now, a globe isn't just, a map slapped onto a ball. No way. It's a true miniature version of the Earth. It gets the shape, the size, the distances between continents. It gets all of that right. That's why it's the perfect place for us to start. And here's a fun fact you might not know. Earth isn't a perfect sphere, not at all. It's actually a little bit squashed at the top and bottom, at the poles, and it kind of bulges out in the middle. Think of it like a spinning water balloon. A globe actually shows this true shape. So how does it spin? Well, here's a super simple way to think about it. Just imagine a needle being pushed straight through the middle of a potato, from top to bottom. That needle? That's Earth's axis. It's an imaginary line, of course, running from the North Pole to the South Pole, and our entire planet just spins around it. But here's the kicker, and this is absolutely crucial. That axis isn't perfectly straight up and down. It's tilted. It's got an angle of 23.5 degrees. This little tilt is literally the reason we have seasons, and I want you to remember that number, 23.5, because it's going to pop up again in a big way. Okay, so we've got our tilted globe. Now it's time to start drawing our imaginary lines on it. Let's begin with the first set, the latitudes. So what are latitudes? Well, think of them like horizontal belts wrapping around the Earth. They run east to west, and they're always parallel to each other. A really great way to picture this is to think about an onion. You know how it has all those layers? Each layer is a complete circle, just like a line of latitude. The king of all latitudes, the most important one, is the one running right around the middle of the Earth. That's the equator. We call that one 0 degrees, and it's our main starting point. It perfectly splits the Earth into two halves. Everything above it is the northern hemisphere, and everything below it is the southern hemisphere. And hey, if you ever get these lines mixed up, here's a super easy way to remember. Think ladder. The rungs of a ladder are flat, right? They go side to side. Latitudes are flat like ladder rungs. It's a simple way to remember that they measure how far north or south you are. Now, besides the equator, there are 4 other really important parallels you should know about. And hey, remember that 23.5 degree number I told you to keep in mind? Well, here it is again. The Tropic of Cancer and the Tropic of Capricorn are located at exactly 23.5 degrees north and south. See? These lines aren't just random. They're directly connected to the Earth's tilt, and they mark out the world's big climate zones. And this is why latitudes are so incredibly important. They basically tell you what the climate is like. The area between those two tropics, that's the torrid zone. It gets blasted with the most direct sunlight, so it's the hottest. Then you have the temperate zones, where the sun hits at more of an angle, giving us moderate weather. And finally, way up at the poles are the frigid zones, which get the least direct sunlight of all, making them super, super cold. Okay, awesome. So we've got our north-south positioning totally figured out with latitudes, but that's only half the puzzle, right? We still need to figure out east and west. And for that, we need our second set of lines, the longitudes. Now, these are totally different from latitudes. Longitudes run vertically, north to south. They stretch from the North Pole all the way down to the South Pole. The perfect way to picture these is to think of the segments of an orange. See how they all meet up at the top and the bottom? That's exactly what longitudes do. So just like the equator is our 0 degree line for going north and south, we needed a 0 degree line for going east and west, and that line is called the prime meridian. By international agreement, it runs right through Greenwich in the UK. This line splits the world into the Eastern Hemisphere and the Western Hemisphere. So let's do a super quick recap to make sure we've got this. Latitudes are the flat ones, like ladder rungs. They run east-west and get shorter as you go towards the poles. Longitudes are the long ones, like orange slices. They run north-south, all meet at the poles, and they're all the same length. Got it? Good. Okay, this is where the magic happens. We have our horizontal lines, our latitudes. We have our vertical lines, our longitudes. So, what happens when we lay them on top of each other? We get a grid, a global grid. And this right here is the answer to that question I asked at the very beginning. When a line of latitude crosses a line of longitude, that single point of intersection creates a unique address, a coordinate, for literally any spot on the face of the Earth. No street names needed. And you know what? This is exactly how the GPS on your phone works. It's not magic. It first figures out your latitude, how far north or south you are. Then it figures out your longitude, how far east or west you are. And where those two imaginary lines cross, bam, that is your precise location. But wait, there's more. This grid isn't just about location. The lines of longitude have this secret, fascinating connection to something we all live by every single day: time. Check this out. The math is actually really simple. We all know the Earth is a circle, right? That's 360 degrees. And it takes 24 hours to spin all the way around. So what's 360 divided by 24? It's 15. That means every single hour, the Earth spins through 15 degrees of longitude. And that, my friends, is the basis for every time zone on the planet. Now, obviously, it would be total chaos if the time changed every time you walked a few miles east or west, right? So, to solve that problem, big areas, sometimes entire countries, just agree to use the local time of one central line of longitude. We call this standard time. It's the whole reason why pretty much everyone in, say, New York has the same time on their watch. So, that brings us back to the big picture. What's the one thing you need to know to figure out both the climate and the time of any place on Earth? It's just its coordinates, its place on this amazing invisible grid. Pretty cool, right?